So what we're going to do is we're going to start taking things and changing what form they're in. Because remember, the forms were useful for us in different ways. What are the forms that we're used to seeing? The standard form, which is the same thing as vertex form. Another one that we're used to seeing. General and factor. These are all different ways of writing quadratic equations. Everything we've worked with has been a quadratic equation. We've just been writing it differently because each form has a different advantage. What's an advantage to vertex form or standard form? It tells you the vertex. How do you see the vertex in vertex form? What are the letters, Soccer?
Your P is your X.
Your P is your X, your Q is your Y. Excellent. What's the use of general form? It shows, not your x-intercept. It shows you your y-intercept. It's your c value. But other than that, general form, just it looks neat. Like it looks nice and clean. That's the only real benefit of it. What's factored form good for? X-intercepts. You need to know those three things because it's going to ask you questions on a test. And you're just going to need to know which form you want to go to. And where to find those things in each form. Very useful. What we're going to do today is we're going to maneuver between standard and general form. Or general and vertex form. Remember, standard and vertex, same thing. It's also called completed square form. And you're going to see why they call it that today. So, perfect square trinomials. Just a little bit of review. We just did it like 2 weeks ago. A perfect square trinomial is something where you can factor it, and it's the same thing twice. So for instance, if we were to factor this, diamond method, 25 on the top, negative 10 on the bottom, your answer would be negative 5 and negative 5. That's how you know it's a perfect square trinomial. It's the same number that either multiplies to get the top or adds to get the bottom. Which means when you factor it, it's x minus 5 squared. This should all be reviewed. That's called a perfect square trinomial. Remember, we use those when we wanted to complete the square. This one, another perfect square trinomial. It'd be 9 and 9. 9 times 9 gives you 81. 9 plus 9 gives you 18. So it would be x plus 9 squared. We're going to need to remember that to be able to switch between forms. We're going to need to remember how to complete the square to be able to switch between forms. So that's what we're going to do to practice. First example, expand and convert to general form. It's the easiest thing in the world to go from standard to general form. Because you don't have to do anything fancy, you just have to expand what you have. Which means we need to do this squared. So it's y equals 2 times x minus 3 times x minus 3 plus 4. Remember, that's what it means to square something that's a binomial. You can't just bring it in. Yeah, it almost looks like that. Yeah. This isn't quite factored form because there's still a plus up here. Yeah, there are two binomials. Okay, factor that out in the middle, or FOIL it out, and you're going to get 2 times x squared minus 6x plus 9 plus 4. The 2 needs to come into the brackets. So it's going to be y equals 2x squared minus 12x plus 18 plus 4. The last step is collect like terms. The 18 and the 4, that's your thing that's like y equals 2x squared minus 12x plus 22. That is general form. So we've converted from standard to general form. That's the easiest thing you can do. When we're converting to this form, the easiest. You don't have to do anything crazy. Going the other way is going to be a little more difficult. Is everyone okay with the steps that I did there? Yeah? Go ahead and try to do the next one on your own. Try to do the next two on your own. Those should have been your answers. If you're not quite done, write those answers down so then you can come back and check it. The worst thing you can do in math is overcomplicate things. So, if you get something that needs to convert to general form, you're not adding anything, you're not subtracting anything, you're just going to simplify whatever you have, or expand whatever you have. That's all you're going to have to do. The negative 6 times negative 6 would be positive 36. Half of that would be 18, but it's negative a half of that, so it's negative 18. And negative 18 minus 3 more. Okay. Going the other way, not so fun. I'm going to skip that slide. It's just some instructions, but we already know all those instructions. They're also in your other notes. Basically, what we're going to do is we're going to complete the square, but it's going to look a little different than we're used to, because when we completed the square before, it was equal to 0. Now we're going to complete the square where it's equal to y, which is going to make it a little bit more confusing. All the steps are the same. You just have to really make sure that you keep your work neat and that you use brackets properly. If you do that and you've mastered completing the square, then this whole rest of the unit will be a breeze. So, convert the following to vertex form. So, the first thing you want to check is if you have a perfect square trinomial. Because sometimes you might already have a perfect square trinomial. And that would be fantastic. Right, Ty? Yeah, I thought so. So, is this a perfect square trinomial? No. That's not a perfect square trinomial. We couldn't factor it using the same number twice. So what we need to do is complete the square. We're going to go step by step. You move the 10 to the other side. So it becomes y minus 10 is equal to x squared minus 4x. Now that we've gotten rid of the c value that doesn't work, we need to add a c value that will work. So b divided by 2 squared. That's going to be the missing c value. B divided by 2 squared. Yeah, what's the question? If there was a number in front here, we would divide it out. There's no a value, so we're good. That's a good question, because we do have to do it. B divided by 2 squared. That's your missing c value that you're going to need to add in. So now it's y minus 10 plus b divided by 2 squared, which is negative 4 over 2 squared, just 4. So we're going to add 4 to both sides. So we've added 4 to both sides. That means we've created a perfect square trinomial. I'm just going to draw a line down here so we mix things up. The side on the left simplifies to y minus 6. It's negative 10 plus 4, which is negative 6. The side on the right is now a perfect square trinomial. So we change it to be x minus 2 squared. Remember, it always changes into b divided by 2. This is a perfect square trinomial. If you factor that, diamond method style, what multiplies to be 4 and adds to be negative 4? Negative 2, negative 2. Now, add 6 to both sides. So we're back to the y equals x minus 2 squared plus 6. So we've converted from, I'll go over it one more time. We've converted from general form to standard form. To do that, we completed the square. To complete the square, you need to move the c value that didn't work to the other side. So that's what we did. Took that 10, moved it to the other side. Then we had to add a c value that would work, because we need a perfect square trinomial. That missing c value was 4. We got 4 because we did b divided by 2 squared. We then factored our perfect square trinomial. So it's x minus 2 squared. And on the left, we just simplified. It's just y minus 6. That's negative 10 plus 4 is negative 6. Then we added the 6 back to the other side. Where's our vertex? Where is it, soccer? Enlighten us.
Your vertex is what? 2 and 6.
That's your vertex. Right? It's your P and your Q. Alright. That's a really easy one. That factors pretty nicely. What's up? Yeah. So your P value reverses, your Q value doesn't. Alright. Next question. We're going to do it again together. Determine the coordinates of the vertex of the parabola in the equation. I'm going to erase the one on top. Is everybody okay if I erase it? Okay. So, you get this question. It says determine the vertex. You could convert it to vertex form. You could. What would be an easier thing to do? Put in your calculator and find the vertex. Now, I'm going to do vertex form because there's going to be questions on your test that you have to convert to vertex form. It won't work. Yeah, like put in your calculator and graph it, and then just find the vertex. If you get a question like that, it's easier than doing the long way, right? It really is. And I don't mind if you quit. Just, yeah, then to go y equals, find it, and then find your minimum point. But, like I said, so those of you who are putting in your calculator right now, stop, because you're just hurting yourself by missing what's actually happening. You're going to need to know how to do it the other way. We've created situations where you have to go the other way. If a question's ever this easy, crap. Questions aren't going to be this easy. The question most likely would be, what is this in vertex form? Then you have to change it. Okay, let's change it. What's the golden rule to this? Take your greatest common factor out. Always your golden idea when you're starting out. So, take out a 2. So it becomes, I'm going to boom! And then, look how good I'm getting at this. What's up, teacher college? Okay, so, take your greatest common factor out. So it's y equals 2x squared plus 8x plus 12. All I did was I took the 2 out. We then, because sometimes the gods smile upon us, check to see if it's a perfect square trinomial. It's not.
That's the most
Right?
math ever.
Yeah, it's not a perfect square trinomial. So we got to do the long way around. So, okay. We could factor that.
Okay.
But it's not a perfect square trinomial. Which means, like, if you tried to factor this right now, Todd, you get 12 and 8, and 6 and 2 work. But it's not a perfect square trinomial because those numbers are different. They have to be the same number to be a perfect square trinomial. So that's no good for us. That would be how you get in a factored form, but we don't want factored form. Okay. We want perfect form. You need to get your C value that doesn't work to the other side, but you can't move it because it's stuck in these brackets. So you have to divide both sides by 2 first. So it goes y over 2 is equal to x squared plus 8x plus 12.
Just take whatever you want.
You could, but then you would have to factor your 2 out later, and it makes it a lot more messy.
No, like
have faith.
Right.
Yeah, you could have done that. That's the exact same thing. Just keep following me. If you got to the same step by doing your way, then you're doing it right. Okay. Move your C value that doesn't work to the other side. So it's y divided by 2 minus 12 is equal to x squared plus 8x. Add your missing C value to both sides. Your C value is 8 divided by 2 squared, which is 16. So it's going to be y over 2 minus 12 plus 16 is equal to x squared plus 8x plus 16. Simplify the left-hand side, so it'll be y over 2 plus 4 is equal to x plus 4 squared. So I factored that right-hand side. And I knew it was a perfect square trinomial because I picked such a beautiful C value. So numbers that would add to the 8, 4, and 4. Numbers that would multiply to be 16, 4, and 4. Just wait. Everybody breathe. Once I've done that, I need to move everything back to the other side. So I need to subtract 4 from both sides. So it's y divided by 2 equal to x plus 4 squared plus 4. Let's start this minus 4.
Everyone's pretty
Now we have to multiply both sides by 2. But be careful when you multiply both sides by 2, because this is where you're going to make a mistake. It stays on the outside, but it also applies to your 4. So it's going to be y equals 2x plus 4 squared minus 8. You have to make sure you multiply everything by 2. So I took this 2, and I multiplied both sides by 2. That 2 applies to your binomial, and it applies to your constant. Not it. It was already a negative 4. So negative 4 times 2 is negative 8. Are we done? Yeah. The question was, what's the vertex?
Oh, 4 negative 8.
Close.
Negative 4.
Negative 4 and 8. Negative 8.
So close.
You were so close and so confident. Stop. Just wait. Guys, Doctor's got a question. I want to hear it. Go ahead, Doctor.
What would be the axis of
That's a great question. What's the axis of symmetry?
negative 4 the x value value?
It's negative 4. Stalker's got a good point. Whatever the x value is of your vertex, that's your axis of symmetry. So if it asks you that, your axis of symmetry is negative 4. What's your x-intercept? I'm glad you're all confused. We don't know. Vertex form doesn't tell you. You'd have to solve it. Right? So that's no good to us. It would be negative 6 and the negative 2 from earlier. Yeah. Okay. That's from when I know that. Okay. Next slide. We're going to run through it again. It's going to be a little quicker. Ready? This is how fast you should be able to do it. The vertex is 2, 3. What? I'm just kidding. It's not. I have no idea. Okay.
This comes too much.
We need to convert it to a perfect square trinomial because that's the only way we know the vertex. To do that, you need to get any greatest common factors out that you can. There are none. So you're going to move your 7 to the other side. Y minus 7 is equal to 3x squared minus 12x. You can't create a C value until you get rid of your A value. Remember from completing the square, that 3 can't be there. So you need to divide everything by 3. When you divide everything by 3, this side on the left, just do that. It makes it easier. We've divided everything by 3, so we get y minus 7 over 3 is equal to x squared minus 4x. It's easier to leave that like that, and in my opinion, put brackets around it, so that you don't forget later on that they're attached. That's the only reason I'm putting brackets. It's just a reminder. That's stuck together.
So when you go to the like values divided by 4, you just go 12 divided by 6. Or I don't know.
4 divided by 2.
Okay. I'm going to show you. Yeah. Yeah, and then you confuse everybody, right? So we need to create a C value. How do you get your C value? B divided by 2 squared. 4 divided by 2 is 2 squared. It's 4 again. So add 4 to both sides. This is why I put the left side in brackets. Because I want it to be y minus 7 over 3. Oh, sorry, yeah. Then plus 4 on the outside. I don't want that divided by 3 to accidentally get attached to that 4. That's why I do it that way. Is equal to x squared minus 4x plus 4. The right-hand side. We can factor that. So we have y minus 7 over 3 plus 4 is equal to x minus 2 squared. I'm going to subtract 4 from both sides because we've finally got our factor over there on the right, so now we can move everything back to that side. Subtract 4 from both sides, and I get y minus 7 over 3 is equal to x minus 2 squared minus 4. Now I'm going to get rid of that 3 over there. I'm going to multiply both sides by 3. So it becomes y minus 7 is equal to 3 x minus 2 squared minus 12. And then add 7 to both sides, and you're done. So y equals 3 x minus 2 squared minus 5. Okay, so let's run through that together. Full recap. As soon as they stop talking. Full recap. I'm going to let you write that down. So just start hammering that out. We had a question. The question said, determine the vertex. We knew we could determine the vertex by putting in the vertex form. So that's what we're going to do. Put it in vertex form. We have to move our no good c to the other side. So that's what we did. So we put negative 7 on the other side. And then we had to divide everything by 3. Because we can't have an a value when we're trying to complete the square. That gave us this equation right here. We then created our perfect square trinomial by adding the perfect c value, which would be 4. We added 4 to both sides. We noticed that the 4 is not attached to that y minus 7 divided by 3. It's separate from it. We then factored the right-hand side. So x squared minus 4x plus 4 factored is x minus 2 squared. Since we've got our factor, we now move everything back to the side we wanted on. We added 4 to both sides, subtracted 4 from both sides, multiplied both sides by 3, and then added 7 more to finish off. Where's our vertex? 2 comma negative 5. Awesome. Emily. Yeah, you get the exact same graph. So if you want to check to see that you did it right, that's a good way to check to see if you did it right. Put in your calculator in y1. Put in your calculator in y2. You should only get one graph. It should be the exact same line. If for some reason it's off, it means you made a mistake. And maybe that mistake is that you put in your calculator wrong. So you got to be pretty confident in your ability to graph, which you should all be good at. Okay. Can you get him his pencil phone, please? It'd be sweet of you. Thank you. So Ty is very grateful. Thanks, Ashley. Okay. Let's see what. Let's fast forward. Standard form? That's a good question. So if we go back to that next question, it says convert it to standard form. That's the same thing as vertex form. Same thing. Ty.
Negative x squared.
Yeah, it does. So we're going to do it. I look back at it. So, erase the world. So if the question was like a multiple choice question, it was like, what's the vertex? Yeah, you get 100%. It's just a multiple choice question.
But if it says show your work.
If it says show your work, it's a written question. It says put it in vertex form, then you got to do it. You get 0. Right? So if we do this question, there's a lot of different approaches you could take. The way I would do it is I would deal with the negative right off the bat. So you always check for a greatest common factor. That's always the first thing you check for, right? There is no greatest common factor. But what you could do is you could take out a negative out of everything. or make everything a different sign. So right off the bat, I could change this to negative y is equal to x squared minus 12x plus 5. And by doing that right off the bat, it just makes your life easy, because now you have an a value of 1. And it's just a simple completing the square. You just know that at the end, you're going to have a negative y, which means you're going to have to change it all back at the end. You could change it halfway through the question, but it might confuse you because you're going to have a lot of numbers that you're changing. Right off the bat, there's like no numbers you're changing. It's easy. So that's my solution to this. Now, it's a standard question. Do we have a perfect square trinomial right now? No. So move the 5 to the other side. We have negative y minus 5 is equal to x squared minus 12x. You're going to have to add your missing c value. Your missing c value is 36. So 12 divided by 2 squared. So it's going to be negative y, negative 5 plus 36 equal to x squared minus 12x plus 36. I'm going to simplify the left-hand side, so it's negative y minus plus 31 is equal to x minus 6 squared. Subtract 31 from both sides. Negative y is equal to x minus 6 squared minus 31. And now we'll reverse all the signs again. So multiply everything by negative again, and you get, I'll write it up here, final answer, y is equal to negative x minus 6 squared plus 31. Be careful, that negative doesn't go inside the brackets, it's outside the brackets. Right? So it's negative x minus 6 squared. Don't change the sign on the inside. You're not allowed to do that. That negative can't go in the brackets, and a lot of people will do that, but don't do that. Josh. Basically what I did was I divided everything by negative 1. Or multiplied everything by negative 1. You're calling how you want to see it. Yeah. TJ.
Oh, no.
Okay. The question was, I'm going to ask you a lot of questions right now because what we're trying to do is get you ready for those hard, true, false questions. Ready? I don't want you to say your answer loud. I don't want you to say anything. Okay, so just stay completely quiet. True or false, your graph has been transformed 6 units to the left. Put your head down and everyone put your head down. The graph has been translated 6 units to the left. Everyone put your head down. Put your hand up if you think that's true. Put your hand up if you think it's false. Put your hand up if you don't have a clue. Okay, you guys did pretty good. Okay, heads up. Remember when you're looking at these graphs in this form, the P tells you how far left or right your graph has moved.
I didn't know what is 6 units.
Yeah, so your original graph.
I thought you were asking.
I'm going to tell you.
6 units. So when you change like 4 and then
Okay, well, this is what I'm going to go over.
when you change 4 to like
This is what I'm going to, no. This is what we're going to talk
but
about.
like negative 6 is your x, right?
So, your original graph that we've always talking about always looks like this. Remember, that's our original x squared graph. That's what our graph always looks like. So when we talk about transformations, we're talking about from this state. Because this is a quadratic. This is your basic quadratic of x squared. This quadratic that we have is this one just moved around. The p-value tells you how far it's moved to the left or to the right. If it's negative, it moved right. If it's positive, it moved left. So this graph has moved 6 units to the right. This and this? No. So they've taken, see this like line right here? This square. I'm going to draw it. That graph right there in red is y equals x squared. It's your basic standard graph. We've transformed it to become this new graph. That's what we've done. It was like our second lesson, maybe our third lesson. Third lesson. Where we talked about transforming things. And we had something in the state of y equals a x minus p squared plus q. It's called general form, or standard form. Standard form or vertex form, right? Because it tells it's standard form, also called vertex form, also called completed square form. Those three things are the same thing. Touch.
So, sounds like is this our graph right there?
No, this is y equals x squared.
Okay.
That's what I said. So I wrote it up and so I drew it in different color.
Okay. That's a negative is less than 1. Less than 1 makes
Right. You graphed it.
No.
You did. You did graph it though.
But I was confirmed with that.
Well, you were paying attention. I've already told you that this is y equals x squared. Awesome. Yeah, that's what I'm saying. So if you're given this form, and this is what I'm trying to prep you for, because this is what you're going to get. You're going to get this, and then it's going to be true-false statements.
You never told us.
It was false, because it's moved 6 to the right. So a negative p-value has moved to the right.
Because you have to change your
Right.
You flip the side?
The p-value is a flipped sign.
Okay.
Remember how we flipped the sign for the vertex?
When you flip the side, you go to the way that it says.
Yeah. So,
Oh, yeah.
right.
Okay. So where you
Wow. So,
So, for example, if it was x plus 6, it would move 6 to the left.
correct. So, this graph, how far up has it moved?
31.
It drew 31 up.
Okay.
Awesome. Is this graph facing upwards or facing downwards? Downwards, because the a value is negative. That's why that negative was so important. So this graph was flipped, and then it was moved 6 to the right, and then it was moved 31 up.
Negative out front comes to left.
Yes. It flips like this.
Okay. And then this you'll have a maximum point, right?
Correct. That's a, yeah. Next thing I was going to ask you is I got a few questions still for you. So where's the vertex? 6, 31. So if I said true or false, the vertex is at negative 6, 31. False. Okay. I give you this. True or false? This graph has a maximum point. True, because it's facing downwards now. True or false? The axis of symmetry is at x equals 6. It's true. So, the way to figure out your axis of symmetry, you first find your vertex, which is that, you guys told me it's 6, 31. That 6 is your axis of symmetry. Because it goes straight through the vertex. If, and here's my golden rule, you can sum the vertex properly, which is why I've been drilling it so hard. The vertex tells you everything. Just looking at the vertex, it tells me how far right I've moved, it tells me how far up I've moved, and it tells me my x-axis, my axis of symmetry. Knowing the vertex, you know everything. The only thing you don't know is if it's up or down. That's what A tells me. Good? We're linking a lot of concepts right now. A lot. Okay. Let's do a couple more. We're going to talk through all those true-false type things again. So, we're going to do the first one together. You're going to do the second one on your own. When we're done talking, that'd be great. Get up your seat. Obviously, not a good spot for you.
You're just so.
Oh.
I finished 3.6 and I don't want to.
Okay. First thing you always do, check for a greatest common factor. Is there one? No, there is not one. So, the next thing you do, move your C that doesn't work to the other side. If you want, right off the bat, if you wanted to change this negative, because that's what we did last time, that's fine. That's fine with me. So if you want to change every symbol, that's fine. You'll get the same answer again. But you divide everything by negative. I'm not going to do that because the 4 that's with it will remind me to do that way. That's the reason I don't do it. The other question, it was just negative x squared. People tend to lose that negative 1 that's up front. They forget that it's there. Okay, I'm going to move my 2 to the other side. So I've got y plus 2 is equal to negative 4x squared plus 9x. What's the next step I have to do? Someone with their hand up.
Make it C.
All right, Logan, what are we going to do?
Divide negative 4.
Yeah, yes. Yeah, we have to divide everything by negative 4 because you can't add your missing C value until that A value is gone. So divide everything by negative 4. Y plus 2 divided by negative 4. I'm going to put that in brackets as a little reminder to save my life later. Is equal to negative x squared. That's going to be plus 9 over 4x. That's going to be negative. I divided everything by negative.
Yeah, maybe same thing minus.
It'd be the same thing as minus 9/4. Same thing. Now I'm going to add my missing C value, which I'm going to take my time with because this is a hard one. It's a hard missing C value. So your C value is B divided by 2 squared. So 9 over 4 squared. This is the same. Oh, sorry, 9 over 4 over 2. No, it's 9 over 4 over 2. So it's 9 over 4 divided by 2. Your B value is 9. Your B value is 9 divided by 4. Yeah, and the negative is still there. Yes, the negative is still there because 9 over negative 4, right? It won't make a difference if you forgot the negative because we're squaring it later anyway. Aaron.
For like completing this, I would just put it 9 divided by negative 9 divided by 4 and then divide the answer by 2 and then square the answer.
Yeah, I think so. See if you get the right answer. If you got lost in your words. So, if you don't know how to do this, which I don't blame you, because that's like way back in like grade 4. In your calculator, go 9 divided by 4. Oh, sorry, I really know your work. Such a stuff. Go 9 divided by 4. Enter. Divided by 2. Enter. Math frac. And you're going to see that it's just 9 divided by 8. When you take your b value and you divide it by 2, it's just like multiplying it by a half. Which means your denominator is just multiplied. It's 4 times 2. The squared, it goes into both things. So it's 81 over 64. That's the value we need to add to both sides. You could simplify 81 over 64 if you wanted. Not 9 and 8. You're not square rooting. Why would you square root? Really, that's not how it works. No, you can't square root that. You're breaking my brain. You could probably. I don't think you can simplify it. No. Try it. Yeah, I don't think it'll work. Yeah, I want to get through this. We're not leaving until we get through it, so I have to stay here till like 5 minutes. So we're going to add 81 over 64 to both sides. Add that number to both sides. You're going to have y plus 2 over negative 4 plus 81 over 64 is equal to x, and it's going to be minus 9 over 8. Yeah, so how did I get from that last step to this step? Yeah, it's a good question, right? What did I do? How did I get from there to here? I added my missing c value, and then I factored it. That's all I did. And that's what it would factor to be. Remember, it always factors to be b divided by 2. That's how it's always going to factor. Emily. If you can, I don't think I give you one this time. But if it ever does happen, be ready for it, right? And if you can do these, you can do the easy ones. That's the best way to look at it. Anton, that's my missing c value. Okay, now I'm going to get everything away from the y. I'm going to subtract 81 over 64 from both sides. I'm going to get y plus 2 over negative 4 is equal to x minus 9 over 8 squared minus 81 over 64. Multiply both sides by negative 4. So it becomes y plus 2 is equal to negative 4 x minus 9 over 8 squared plus, and 81 over 64 times 4. What's that give you in math bracket?
16. It's 81 over 16.
Thank you.
Because you just divide the...
It was negative 81 over 64, and I multiplied it by a negative 4.
Oh, right. So you can...
I then subtract 2 from both sides, and I'm done.
And that 81 over 16, that's like term of the 2, right?
You would have to make it like terms, yeah. So to add 81 over 16 plus 2, putting a calculator, hit math frac. Go 81 over 16, and then go plus 2, and then go math frac. And it should give you, let's give you 1.
13 over 16.
Oh, it should be, yeah, that's right. It would be 32 plus 8. Where's your vertex? 9 over 8 and 113 over 16. That's your vertex. Where's your x-axis of symmetry? 9 over 8. How much is this graph translated to the left or right? 9 over 8, which direction? Right. How much has it transformed up or down?
6.
Up. Is this graph facing upwards or downwards? Downwards, because it's a -4 front. Maximum or minimum point? Maximum point. Okay, move your desk back.